Okay, super. So let's see, we're a little about three after. Again, we're going to be diving in how to streamline your data ingestion. Why don't we, while we're waiting for folks to get in, let's just run through the agenda here. So we're focusing today on streaming data acquisition and processing, along with incremental ingestion and transformation into a data lake. And we call this universal data workflow that we're going to be covering. So while we let everyone in, let's run through the agenda. We're first going to talk about data architecture, some of the trends and problems that we're seeing out there, and why we think these technologies solve these problems. Then we'll get into a product demo to show you how to implement this architecture. And then lastly, we'll wrap up with the big idea, what we call this universal data workflow, introduce you to Confluent and Onehouse and our managed enterprise grade solutions and how you can get started with them. And for folks that are new to all this, new to Kafka, Kafka is a distributed streaming platform for building real-time data pipelines and applications, while Hudi is a data lakehouse framework that provides efficient updates and deletes and incremental data processing on top of low-cost cloud storage. And as we're going to show you as we go through today, these two technologies complement each other very, very well. So we'll see that. So how did I do? Did I explain Kafka okay with there, Will?
Works for me. We'll get into it.
All right, awesome, awesome. Okay, we're five after. I think I'm gonna jump in. We'll just do some introductions. So, I'm Cameron O'Rourke. I've been, in the data space for, geez, a few decades here. I was at Sybase. I spent a couple decades at Oracle actually, and then been at a number of data and analytics startups after that. So, been in data all my whole career, working with it. How about you, Will? And I got to ask you, how did you get this title, Intergalactic Field CTO? It's on your LinkedIn. I've got to hear the story behind this.
Well, if it's on LinkedIn, it must be true, right? Yeah. So I'm Will Forrest. I'm a field CTO at Confluent, one of two. And the reason why I'm an intergalactic field CTO, first of all, I will confess that I actually support a number of customers that have space missions. So that's the first thing. So there is,
Okay. Okay. I see where we're going.
Whether or not they've got to another galaxy is another matter, but they're going to get there. And the second reason is my counterpart, Kai, listed his title as Global Field CTO. So I decided I had to one-up him and become intergalactic. So
I see. Yeah. And and originally I put down galactic and just my dude, I had to check to make sure, and you're sure to correct me on that. So I did not get the title wrong. So I'm happy I did due diligence in that area. So let's get going. So we're going to be discussing some of the problems with current data ingestion and data storage and data movement architectures and what we believe is a future-proof solution. But first, we need to talk about why this is an imperative for business today. So I've listed 4 trends that I think matter here. And the first one's, coming out of COVID, we all felt the need to quickly adapt, right? Just making small changes didn't cut it anymore. Business had to literally pivot or die, right? And I don't know if you remember that, but so this notion of agility took on added urgency and weight, and everybody was scrambling to change. And this old idea of batch processing our data didn't really work as well as it did before. And companies found that they had to begin to analyze data in real time, and streaming data ingestion and even stream processing has really come to the forefront in data management. Now, at the same time, there's been this shift in approach towards data acquisition, data movement. Whereas before the idea was more is better. The more data we can get and we can pull together, the better we're going to be. And lately there's been a shift, and this is especially in the areas of data science and machine learning. The focus has really shifted to data quality. So the more quality that you can feed the models, the better the models are going to be. And then, the final pivot focuses on moving off this landscape of diverse siloed use cases, right, supported by separate data warehouses or data lakes, towards a more unified, connected architecture that allows different use cases to all be using the same data, getting the same answers, and utilizing data better and hopefully at lower cost. So let's dive into some of the problems. So with that, I'm going to turn it over to Will for just a minute, and he's going to cover some of the issues around data movement, and then we'll move on to data storage.
Awesome. Yeah. So, what I'll probably do, Cameron, is I'm going to start with sort of this historical divide that we've seen in data management world where, enterprises have really sort of separated into two separate estates. So on the one hand, you have your operational systems, which are designed to support the needs of your core business functions and applications. So these are things like your order system, processing financial transactions, building apps for your customers to interact with, et cetera.
Mm-hmm.
And on the other side, you sort of had or have your analytical estate, which is really exists to analyze the data, slice and dice it for reporting traditionally. And the data from the operational estate needs to find its way clearly to the analytical estate. That's where the crown jewels are being generated on the operational side. And traditionally, this involved some sort of batch jobs, ETL, maybe bespoke code, hit APIs. And then this data was then shipped in batches into a data warehouse. And, I think this approach worked okay for a while. Like if we go to the before and after, you can kind of see how that would get us where we are. As long as the data flowed from sort of a limited number of upstream operational systems into a very limited number of downstream analytical systems. And yet I would say, even though this was functional, the data in the analytical side, wasn't particularly fresh. So you were typically looking at stale data, sometimes a day, a week old, right? So the world now is much more complex, right? And it's only getting more and more so. On the operational side, we're constantly seeing new apps getting rolled out, serve new use cases. There are new operational database technologies coming online, like constantly. Every time I turn my head, there's some new really cool database out there to support those apps. But really, as an enterprise, we need to stitch these all together one by one, since even within the operational state, they need to exchange data, right? But we also need to still get this data over to the analytical plane. And meanwhile, what we've seen is the analytical estate isn't as simple as it used to be. And I know that's one of the things that you guys are working to help solve. So in the old days, you might just have like a really old data warehouse, but this has really turned into data lakes, lake houses, and then you have some like really specialized variants for very specific analytical problems, things like feature stores, for instance, right? And it's not just a matter of getting, the business becoming more and more complex. It's also becoming much more demanding about the timing. So you talked about how before it was batch and now it's real time. It's because customers are demanding that. Like that's how you win the best, most immediate experience. And so, slow was fine when technology was sort of a supporting function of the business, but it's not okay when the technology is the business. And I think we've all seen that's what's happened across all the different industries. Working with yesterday's data is no longer sufficient, and incorrect, incomplete, low quality data doesn't cut it. And this means we can't just take the data and flow it in one direction in big batches, right? And that changes the way you need to think about things. The operational estate is no longer just powering the analytical estate. It's actually also critical that the analytical estate now informs the operational side and in real time. However, across pretty much any enterprise you look at, if it's mature, teams are finding it really hard to integrate this data across all these different applications and systems and teams and different analytical approaches. And what's really holding them back is sort of this legacy data infrastructure. And, it looks something like this, a mess, right? This untenable a number of point-to-point connections that's pretty rigid, it's complicated, it's expensive. And it ultimately what this means from a business perspective is it just makes it too difficult, too time-consuming, and cost prohibitive to innovate. So like, I'm sure that's not the first time you've attended a webinar and you've seen a big messy picture like that from someone. And there have been a lot of technologies that have sort of been introduced and positioned to try and help address that challenge. And when I talk about the creation of Kafka, I think it's really helpful to come at it from that perspective, because that's where LinkedIn was, right? So when they approached the problem, they were having the same issues. It was just too slow and expensive anytime they needed to build something new, and they needed to get that data to the analytical side. And they had used ETL messaging and ESBs, like with varying degrees of success. So when they started, they did what any smart business would do. They'd say, let's look at the technologies we're familiar with and we've invested in, right? So they start off with ETL, clearly very helpful in terms of extracting data and doing mapping and then stuffing it into a new location. But I think they quickly eliminated that as an option because it was just, first of all, it was still batch oriented. It couldn't really support the throughput they needed. And ultimately it was a point-to-point approach. It may have been centralized, but it was still a bunch of point-to-point connections. Messaging, on the other hand, sort of held out that promise of decoupling data products, data producers and consumers, and they had a ton of experience with that. But sort of in the lengthy series of efforts to try and leverage that more effectively, they ran into a few issues. For one, none of the messaging products that they used and evaluated could really scale close to what they needed without some fairly extreme bespoke design patterns and awkward limitations. And also, they needed something that could persist the data and enable replay across potentially hundreds of different consumers. And there were limitations of how fault tolerant and durable they were. And even if they could have overcome all that, PubSub is really only a piece of what they needed to sort of untangle that mess. They needed this robust data integration and transformation on that source data, on these streams of events that happened in real time and allowed it to flow through the system. And I always like to say, if you're doing your data curation and transformation in anything other than real time, it means that no downstream system can do any better, right, than whatever the slowest part of the process is, whatever the batch process is. And ultimately, this means also separate processes for the same data to support different needs, because ultimately someone's going to come to you and say, actually, I need the data a little bit faster, so I'm just going to dump that into a message queue or something. Now, ESBs kind of provided some of the means to deal with the data integration on top of messaging, but it actually didn't really alleviate any of the shortcomings of the data plane. And on top of that, ESBs took this sort of classic approach of pattern abstraction into awkward and complicated configuration messes. And I'm sure, Cameron, you've been in the business for a while. Anyone who's done, tried to encode programming inside of configuration knows it's just not pretty, right? So ultimately, in 2010, they reluctantly, I say reluctantly, I don't know how reluctant they are. Anyone who's an engineer loves a new project, but they started to work on a new technology to address this problem of how to enable data to flow across their enterprise in real time in a way that decoupled the producers from the consumers, in a way that reliably ensured fresh data from their operational state, made it to their analytical state, and thus Kafka was born. And about a year later, it was open source, and adoption was really rapid, right? So rapid that the engineering team at LinkedIn couldn't keep up with community interactions, so they left and founded Confluent in 2014, really with the mission of helping customers successfully adopt data streaming. And that was sort of the problem that Kafka was addressing.
Wow, thanks, Will. Yeah, you really hit some points there. I remember, these problems so well, especially with the enterprise service buses. Man, and before that, so many more technologies that came before that, have really been helped by this, these new innovations. So that was data movement. I'm going to talk now about the data storage side of the equation. And in a recent video that I put out for Onehouse, I discussed how we have these two primary architectures that have emerged in the space. And there's a link there if you want to go check that out and copy it down. But in short, data warehouses, right, have been used to take structured business data from operational databases, operational systems, and transform that into a model that delivered fast query results, basically for analytics and business reporting. And then you had data lakes. These handled the less structured data, event streams and other high velocity sources, right? IoT. And they were there, they were there needed to support data science and machine learning use cases, with Hadoop and MapReduce and all that. And this mostly worked, right? We had data warehouses focusing on data governance. They were supporting dashboards and query tools. You had your Tableau and Power BI and everything. And then you had the data lakes focusing on data flexibility. So the high velocity data streams, the click streams and all that. And they were very cost efficient for those big data sets. Now, the problem was in practice, maintaining these two architectures, having to duplicate and reconcile the data between them is super complex and really, really difficult to manage in practice, when you're dealing with, sometimes thousands of tables, right? But even worse is you have this potential for errors to creep in, right? So differences in the two systems and poor data quality. And this is bad for your data scientists to not be building models, right, on the same data as your data analysts. This is really bad because when they go to put the models in production, they don't work because they're using different data than is actually out there. I've seen this time and time again. So all that work, and they have to go back to the drawing board. So the other thing is a lot of these systems utilize very proprietary tools and they want to lock you in, right? You give them your data and then you can't get it back out the way you want it. You lose control over your data estate. So this situation is not ideal. Suffice it to say, data engineers have a lot of problems to deal with today. I'm not going to read all these. We don't have time for that. I'm just going to hit my pet peeve in these is I think the vendor lock-in. I think, if I'm architecting systems, I want to have that control. I want to be able to be flexible. I want to be able to evolve, and I don't want to get locked in, to some proprietary format or tool or whatever. Will, what's your pet peeve on this list? What are you seeing out there?
Yeah, I mean, I would say it probably falls into the data quality, consistency, governance, and that's really, one of the problems that I see oftentimes is you have this really valuable data in your operational systems, and you want to get at it. Like your analytics says, if only I had the data, I could do amazing things. And then some other systems like I could optimize supply chain, whatever it is. And I think there's been this tendency to say, okay, that's great. So I'm going to send this raw data to all these people that want it, and they each have to figure out themselves. And it's just highly problematic. So that's why it's really critical. Like my opinion is to really think about this data and apply the governance. Don't give raw data. That's like an anti-pattern. Create these data contracts, these data products that are sort of decoupled from the sources.
Perfect. Yeah, I agree. I agree with that. All right, guys. So this is what we want to propose to you today. We're talking about these two open source technologies that have revolutionized data management, really, and that together create this architecture, right, that can finally bring data flow, data storage, data processing together into one unified workflow, right, that works really well together. Will, are you kind of agree with that?
Yeah, no, absolutely. I commented a little bit later in the context in another slide, but yeah, totally. They're like I said, PBJ. I can't remember.
Yeah, I was gonna say peanut butter and jelly, coffee and donuts. Awesome. Cool. So let's dig a little deeper into these technologies. Why don't we unpack Apache Kafka, and then we'll go into Apache Hudi, and how these technologies accomplish these things, and why they work together so well.
Yeah, awesome. So really the design of Apache Kafka revolves around this idea of an append-only immutable commit log, right? And what this means is that when new data, these events, are sent to Kafka, they're appended to the end of the log, and then anyone who has access to it can read that data when and at the rate that they want. including receiving a constant stream of new events as they're published. And the writing and reading of this data into these logs is done using this pub-sub metaphor. But unlike the traditional pub-sub technologies, the data is stored and brokered in this incredibly scalable cluster. And it's done for, maybe a few seconds or hours or days. And we even have use cases where you'll see these events stored indefinitely, right? Just sort of depends upon the use case. And then finally, one can process these streams of events as they're published in real time. And that's critical, right? What you're not doing is going back and scraping through the events and doing it in a batch. Like you're processing them as they come in. And so typically in the data streaming world, you'll refer to this as streaming ETL, but it's not really streaming ETL, is it more like streaming transformation, but everyone says ETL. Now, one thing I think to mention, specifically in the context of Hudi, is that this design is perfectly suited for streaming these state changes, right? So I have this upstream system, it's my inventory goes down. That is a state change, and I want all the downstream systems to consume that. And if you look at, like, if you peel back any database, what do they have for their state changes? They have this log, a transaction log. So it's like perfect made for this. Then if you look at Hudi, like the UDI in Hudi stands for upserts, deletes, and incrementals, right? So it's like perfectly, in terms of an analytical technology, it's perfectly suited for getting these high velocity set of state changes and being able to ingest that. And I think one of the reasons why Apache Kafka has gained so much popularity is really this sort of the simple fact that between the pub-sub and this data brokering approach, it's allows you to sort of completely decouple systems, right? Additionally, it sort of allows you to standardize your schemas for downstream compatibility. And enables this in-flight processing, so you can combine any stream from really any source for an enriched view of the data. So unlike a sort of a simple fire and forget messaging system or pub-sub, Kafka enables this these data-dependent systems to continuously act upon and react to the most up-to-date enriched data sets. And of course, one of the key points, this helps bridge the divide between the operational state and the analytical state, because the same real-time data products that are feeding your operational apps are also feeding your analytical systems. And you know what's really handy? Having an analytical technology that can actually leverage high-velocity real-time data products, right?
Awesome handoff. That's super. Yeah, that's right. So on the data storage side, obviously we'll mention we need the ability to take in these data streams at high speed and with low latency and make them available for data analysis. And so, earlier I mentioned some of the issues with data warehouses and data lakes, including having to duplicate the data. So here's another view that takes that idea a little further. So the data warehouses, again, support the business intelligence and analytics and are good at supporting queries, Tableau or whatever. And there's this aspect to them that they can handle changing data, the updates and deletes, the change logs that Will was just talking about, so that the data stays in sync with the business. But they've always had a hard time keeping up with those very high velocity data streams coming off, marketing or Internet of Things applications. And the data lake, of course, is able to take in these vast quantities of data and maintain that, detail needed for machine learning. But the big trade-off was that it's essentially write only, right? It's, you can append data into it pretty easily and, efficiently, but it's a very expensive operation to fold changes into the data lake. And we were stuck with these two options, right? Having to maintain both of them to support our use cases. So more recently, the data lakehouse has emerged as this solution that combines really the best features of data lakes and data warehouses into this single converged architecture. And we now, with these, have the ability to handle high velocity data ingestion coming off of Kafka and streams, and with fast queries, all on this relatively inexpensive cloud storage. You also get the data governance and the data quality capabilities of a data warehouse, but with the flexibility to handle not just structured, but semi-structured, unstructured data and so forth. So really data lakehouses have been able to come in and sidestep the limitations of these older architectures and give us what I think is a much more versatile and future-proof solution. So Hudi actually came in, it's a next generation data lakehouse platform that was specifically built to ingest these high velocity streams and these changes, right? It was actually invented at Uber, and to process all the changes in state that were, oops, sorry, hit my microphone, that were happening in there, right? And support that incremental processing. So what is incremental processing, you might ask? Well, it's the opposite of batch processing. So if we take in data and we want to transform that along the lines of, say, bronze, silver, gold, we need to read in that data and add it to our existing data. We have to probably aggregate it or filter it or otherwise transform it, and then write it out to a new set of tables. And this remains a very expensive operation. Can take a lot of time, but especially for a data lake, unless you can apply the changes incrementally as they come into the system, applying just the changes to your downstream tables, it can still be very expensive. And this is what Hudi is designed to do. So instead of reprocessing the same data over and over again, like you would with batch ETL, right? You apply incremental processing on the new incoming data, and you just update the data lake in place, right? And this is why Hudi's great for consuming streams. It allows you to ingest and process and deliver your data to within a few minutes, actually, of your business systems at a fraction of the cost of using something like, and I used to work for these companies, a specialized in-memory real-time system, right? So there's a lot more to learn about Apache Hudi. We don't have time for all of it, but it has an open source services layer for things like clustering and compaction. It has transactions, concurrency, time travel, all these database attributes, but on a cloud storage, right? It keeps it on it's low cost cloud storage like S3 and other things. But it's the most important thing, it's in this totally open format that's available to any kind of compute or query engine. So we've yapped a lot. It's demo time. I'm going to go off video just for a second so that I can concentrate on this, and just a little bit of setup first on what the scenario is here. So this actually came from a real situation that I was involved with. It wasn't that picture Target. It wasn't Target, but another really big retailer. And they had a problem in that they had, like 3,000 retail stores. I think it was even higher than that across the United States. And around the holidays, they had an average of like 8 checkout lines open per store, just running all the time, and they were just millions of scans. And what they needed to do, they actually set up these war rooms where they would sit in a room and they had like, TVs and charts and graphs on the wall, and they would sit there and try to outthink the competition and, in terms of pricing and everything. And they'd be adjusting price. I don't know if you've seen these little screens like in Best Buy and other places where they can adjust the price like remotely. It's like a little, like a LCD screen or something. And they can actually adjust the price from the central office anytime they want in the store. It's crazy. And so they're sitting there like trying to game this, during the holidays, what promotions they should run and everything. And the problem was that they had a really hard time bringing all that point of sale data together. What's selling in the different stores right now, right? So if they issue a promotion, they want to know, hey, in 15 minutes later, are we seeing some action here, right? I mean, it's down to that level of granularity. I mean, I had no idea. Crazy. So this is the technical scenario. I'm going to start over here on the left. So I actually have a little data generator I wrote. It's just generating transactions. So, millions of scans, all the time. And then we also have a set of tables, like it's the item, the product catalog, category lookup, prices and stuff, some lookup tables and things that are changing. And we're actually updating prices on the fly. So I've got a program that's just sitting there updating prices and doing promotions and things like that. So we're getting changes and changes in state into the database. And this is being picked up by Debezium, which is really good at picking up those change logs, those database logs that Will talked about earlier. All this is flowing into Confluent, into Kafka topics in Confluent, where we can see them and process them. Onehouse picks up those topics, those streams, and puts them, does a couple things. It creates metadata around that so that we can use query tools and things. But it also goes ahead and stores that in our data lake, constructs a data lake for us on S3, low-cost cloud storage. But the really cool thing is that once it's there, we actually have metadata available for any query engine, any kind of compute. So let's say we're in Spark and we're in Databricks and we're doing data science, right? We're probably going to want to use Delta Lake table format to read that data, and we can do that. And I'll show that in a minute. We might be doing some data engineering, maybe DBT. I actually have a DBT process running on this to go from bronze to silver. I might be using the Hudi native. I might be using Iceberg. I could be using Iceberg table format if I'm going into Snowflake, right? So really, this is why I say it's universal, because you can really use it for anything, all these use cases, all this compute anywhere. So let's see what this looks like. So I'm going to go into Confluent. So here we are in the Confluent Cloud app, and I love this because it makes it so easy to set up Kafka and manage Kafka and everything. And I want to start, Will, over here. I'm going to go into my cluster that I set, and I set all this up. And I mean, I'm brand new to it, and it was easy. And I got in here and I was able to get all this stuff going. But what really impressed me, and maybe you could talk about this a little bit, is all these connectors that you have available for connecting to just about everything.
Yeah, exactly. And I think the beauty of it, if you're familiar with Kafka, the open source project, really, there is a very rich set of connectors for getting data in, and of course, sending it to the technology you want, like Onehouse. One of the things that Confluent's done in Confluent Cloud is they're fully managed, right? So you just pick one of these connectors and we manage it for you. You just put in the configuration and we take care of the rest. And that just alleviates just a lot of cost and operational complexity for you.
Yeah, I mean, this list just goes on forever. I imagine you can hook to just about anything, and that's really cool. So all these data sources can be,
or even upload your own custom connector.
Oh, there you go. There you go. So really, I mean, all these data sources can be streams coming through the system. Let's see. I have a few connectors. Actually, we have some Debezium connectors that were set up. I'm going to explain how they were set up. Well, actually, I'll explain it now. We'll see that a little later. But these were actually, they say OH, these were Onehouse connectors that were set up via Onehouse. So we actually provision these automatically and to set up that change data capture. But you see the regular connectors running right here in the Confluent environment. Nothing hidden up our sleeves, so to speak. The other thing, let's take a look at some of the topics that are streaming in here. These are just heartbeats, so I have my let's see if I can make this a little bit bigger. I have my store, my products, my item master, all these lookup tables. These are all being streamed in, change data capture. The main one is my scans table, right? This is where, I have the bulk of the data coming in, and I can come in, of course, I can see, what's being produced, the number of messages. I can get in here and I can look at the messages and what's going on here. I love this. I can get in, I can see the schema. I can modify the schema. I can version the schema if I want to and bring things forward. I can manage the configuration, all super, super easy here. You were telling me about this other thing the other day, this data portal. This is really cool. What's this all about?
Yeah, so I think really the idea here was, in a mature enterprise, you're going to have all kinds of these sort of what I would call fresh data products. And so if I'm someone who's like, let's say I'm on the Onehouse side, or I'm on the analytics side, and I'm like, I want to optimize my supply chain. So I want to get point of sale data, and I want to get something else. Like, how do you know which of the potentially thousands of topics inside of Confluent Cloud is what you need? And so what Data Portal does is it allows you to search across all these different topics. And then, of course, you can see metadata. So in this case, Cameron, you can see a data product. There's been like 2 topics that have been tagged with this notion of data product. And you can think of those as being sort of the blessed, sanitized topics that can be consumed outside of the domain. So in this case, we just picked the scans and the master. In practice, like those would actually probably be, we'd use Flink to perform like an enrichment. So they're more of a data product rather than sort of the raw data, but it gives you the idea. And so this really just gives you a way to explore the data. So there you can see
click that query button there.
Yeah, you hit the query button. So I see Jin Lee asked a question about Flink. When you hit the query button there, that brings you to this developer portal for writing Flink. Now, when you express a query in Flink, which is what you just did there, Cameron, what it's actually doing, it's actually spinning up a stream processor in the background, right?
Yeah.
So right now we're just using it to explore the data. But like in the real world, you would probably do streaming ETL. Like I'd say, I want to join this stream with another stream, and I want to do a projection, and maybe I want to bin something temporarily. And then the output of this constantly running query, this Flink query, would then be produced to another topic. And then that topic would then be sent to your downstream consumers, Onehouse being one of them. So Jin Lee asked, like, how do you use Flink in conjunction with Kafka to feed Hudi? I mean, that's sort of the answer. Like you have your raw source data coming from Debezium and your scans, you apply Flink to produce an enriched data product. The results of that is then materialized into a Kafka topic, and then that's what goes to Onehouse or other operational systems.
Yeah, that's a great point. Yeah, so Flink works right in here, and it's how you'd probably I was getting ready for that. I was geeking out on this workspace, and these guys know I was in here, and I didn't have time to really learn it. But this just looked like a fantastic way to get in and really work with those streams and create new topics and everything. Really impressive. I'm going to jump over to Onehouse now so we can sort of see what's happening on that side. I'm going to not hit all this, but let's start with the catalogs. So one of the first things that we do when you begin using Onehouse is you're going to set up the kinds of metadata catalogs that you want to populate, right? And of course, that's so that you can use these different facilities. There's one that's specially for Snowflake that we have. Snowflake can also use iceberg tables, but we have one that specifically writes Snowflake metadata. We have the one table that does Delta Lake, iceberg, and Hudi, and others. So you want to set these. So I've set up a couple catalogs. We're generating the metadata for those things. The next thing that you generally do is set up your sources. So sources are things like Kafka streams, S3, databases, what have you, and you're just setting up basically your credentials for hooking into these data sources. And then what you do is you set up a thing called a stream capture. This is your job to actually ingest the data into your data lakehouse. We can see that I have a few running. I'm actually going to add a new one here just on the fly so you can see how it works. And I do have another table out in my database. It's called a promotions table. So I'm doing my promotions, my price reductions that I want to do. And I can come in here and I can just choose the data source that I've set up. So we had the Confluent Cloud CDC set up. I can go mutable. So this could be changing data that can update and have deletes and all that, or it might be a write-only thing that just depends. This particular stream happens to be append only. It's just a stream of new promotions coming out. So I'm going to choose append only on this, but most all of the other streams we have running are mutable at this point. I'm just going to set that to 1 minute so we don't have to wait on it. And then I decide, so here, it's already read in the tables that I have available on my database side through Confluent, actually. And I'm going to configure that. And when I come in here, one of the things I can quarantine invalid records. So if a record is bad, it doesn't match the schema, it'll get put in another table so we can deal with it later, which is nice. And then I can add transformations to the data coming in. And one of the things I need to do is convert it from that Debezium change data capture format with kind of the before and after pieces to it into just a row. So this is coming in from Postgres, could be coming in from MySQL or Mongo or other places, but this converts that record into the format we need. I do need a key. I'm gonna choose, I don't have a great key here. I'm gonna just choose item, and why don't we go start date? That'll work as a key. And we don't need to do those. And then we pick, where's it going? It's going into my data lake. It's going into my bronze section. So I kind of have a bronze, silver, gold thing going on. So I'm putting it in bronze, and then I'll go ahead and choose the 2 catalogs that I want to populate. Just make sure I did everything correctly, and we'll just get that going, and we'll revisit that in a little bit after that's had a minute to provision. So let's see, let's pop over to the data section here so we can see some of the data that's been coming in. Again, my main, the retail scans is this batch scans, and it comes in batches and gets unpacked into individual records. And let's see, so we can see that, there's some records, 22 million records, the storage size. It tells us everything we need to know about our data lake right here. We can see the data coming in over time. Over the last few days, I've been running this generator. I was doing something on the 24th. I stopped it, but you see about, 4.5 million rows a day coming in. So we can look at all that. Let's look at another one here. I like this item master because this is what's taking the price changes, right? So it's coming in, and then what you can see, okay, so what happened here is like back here, I put all my 32,000 products in, and then since then it's all been price updates. So these are upserts, these are updates into the data lake being handled here, and you can see that. Other cool things about this is that the optimization, so the Hudi processes are all managed from here. I don't have clustering turned on, but things like compaction, reclaiming space, cleaning, that's all managed from here, and you can monitor that as well as the whole history of operations. So here was a cleaning job commit. You can see rows coming in here, and whatever is going on in the system. So super handy for managing this whole thing all from one place. Now I want to point out, I'm going to jump over to AWS here where this is all hosted. Okay, so I'm going to start over here by Glue. So this is our Glue catalog, and Glue is a metadata database, right? And I want you to notice that I have these databases. I have bronze and silver. So this bronze is this here, is this bronze, is this data lake, is what that is. This gets created for you automatically. Now, if I click in, I can see the tables that have been created, the metadata that's been created on these tables that exist in the data lake for us. Now, I don't know if you guys are familiar. So RO in this world, in Glue, in this AWS world, means read only. It's fast, and RT means real time. So it's just 2 different service levels that Amazon gives you. So they do that. But here's all our tables. This is all the data that's in the metadata. And of course, I can come into something like Amazon Athena and make queries against that and run queries. I'm not going to rerun this, but you can see the data's coming out and so forth. And in addition, let's go over to S3 where the actual data lake is stored. Now, I want to point out, this is your account. Like, it's not our account. This is your account, right? This is your buckets, your S3, your processes. It's not hidden, but you're in control here, right? We're just coming in and we set this up for you. We take care of all the hard bits of configuring and everything, but this is your data, right? You're not getting locked in here. So here's our bronze stuff. I can come in here, and here's all the different places in the bucket, the folders in the bucket that have this. So there's a folder for each table, and then there's a quarantine folder for records that get thrown into quarantine. Pretty cool. And of course, you want to use this. So I've got a couple query engines here. I don't know. I just like Mode because I get a free account. It's easy. But this could be Tableau. This could be Power BI. Those aren't free. So, but this is, and you come in here and run these queries against it. I mean, just this kind of typical analytics stuff, right? I have a chart. So I have my top 10 products there. I have another one over here, another query, top regions, and a pivot table. So it's typical analytics stuff. But the point is that I'm going here and I'm using those open table formats to use any tool that I want. So analytics, what if I'm a data scientist? What if I'm working in Databricks, right? So here we are. I'm in Databricks. I have um, my project that I'm doing. Maybe I'm trying to do some data discovery or what have you. And notice right here, the format that I'm reading is Delta. So I'm reading Delta Lake format, even though it's stored in Hudi, natively. We have all the metadata you need to use it anywhere, right? And this can actually even speed up, these Delta Lake, Databricks operations, because we can deliver that data quickly. So I won't go into all this, but I wrote a little thing here, and so we're doing some work with the data, and we come down, and we're, and I made a little plot just to show, okay, we're, maybe we're doing a data science project, and we're trying to discover stuff. So the idea is I can do analytics and data science, aggregate data and detailed data all in the same system. Really, really cool. So let's just go back. I'm going to just take a quick peek to see if this guy updated. Looks like it did. So let's see. I'm going to go back to Confluent. I'm going to go in here. And when I set up, remember I set up that that data stream for the promotions. So I'm going to come in here, and with any luck at all, we should have a new topic that has been provisioned for us. This is where live demo gets really hairy, because I could have done something wrong. I ran through this like 5 times yesterday to make sure it would work. And now I'm not seeing it. So let's go over here and see what happened. I bet you anything. I can see the promotions table here. So that was created. I can see the stream capture was created here. Oh, I did something wrong again. Yeah, okay. So I mistyped something, guys. I'm sorry. But what would happen normally is, so the Onehouse would provision this. It actually provisions everything. It provisions the connector and the CDC, and it's really easy. And I'm sorry, I practiced it so many times, but I must have screwed up. But it actually creates that here and creates the data and the stream and everything for you. And it's super quick and easy. And normally it works awesome.
And this is, if you don't mind, Cameron, this is a really critical mind shift that's important for everyone to understand. It's no longer a unidirectional thing. I'm not just sending my business data to the data lake to have it be off in a silo and analytical people doing analytical things. My smart data scientists, they're using whatever tool they want to on top of Onehouse, because you can see you can use Databricks, you can use it in Snowflake, you can use it in Trino or whatever you want. But the output of that is itself extremely valuable. And you probably want to consume it as a stream of results in other operational systems. So now you have the analytical stuff informing your operations. And that's really what we want. We want this constant flywheel effect of extracting the maximum value using the right tools between these technologies.
Okay, somebody wants to see the failure message. I'm pretty sure I knew I'm pretty sure I know what I did. And I think what I did, and I keep doing this, I keep forgetting to delete the old promotions metadata out there, and that's what's messing it up. And I'm just very sure I forgot it again. And I'd have to go into the logs, guys, and see. I know what I did, though. I forgot to delete the old one, and that messed us up. Sorry about that. Let's moving on. Let's get back into the slides here. So what this hopefully shows is, it's this nice, converged architecture, right? I hope what you guys take away from this is that we're showing this unified workflow that lets you shift from multiple kinds of data pipelines to this single universal way, I think, of moving data, and from different kinds of storage into a single storage format, right? And combining these separate workflows to a single streaming incremental workflow. We can finally stop copying data and create one place, which is what I like about where we do data acquisition, refinement, validation, governance, and analysis. And I think now let's just really wrap up. Let's get into kind of why Confluent and Onehouse next. Why what we bring to the table. And I want to talk a little bit. We have a company that's common to both our companies, Notion. They were really able to benefit from this architecture. Notion's data, an application that users get in, create blocks, and anyway, there's a lot of data that is very random due to the way the users interact with it. They very quickly escalated to like 10x the amount of data in 3 years. They have a 50 terabyte footprint, and that's compressed with about 100 terabytes active. So hey, well, why don't you talk a little bit about what the story is from your side, and then I'll get into how we've interacted with them.
Yeah, I mean, from our perspective, I would say sort of the Notion story is maybe a pretty typical one for Confluent, right? And the idea was, how do they make sure that the various data stores and language models that they're using, because they're really a productivity tool, leveraging AI, like how do we make sure they're as fresh as possible based on updates to content and user behavior? And if anyone's interested, like if you take a look at our second day keynote from our users conference last year, Notion was on stage talking about why data streaming. And so that user conference called Current. So that's a great place to find out a little bit more.
Oh, perfect. Perfect. Yeah. The first data warehousing attempt that we know about saw them, ingesting their data via Fivetran in the Snowflake there, but they ran into this trouble keeping up with the all the bursts of data that the users would generate. And it turned out their hourly loads were taking longer than an hour. I mean, where have we heard that before, right?
Yeah.
And they would sometimes, lose state. They'd have to resync, and this is all getting super expensive to do on Snowflake with all the volume of inserts and updates in the Snowflake cluster. So they were able to switch to this new architecture that ingests data from Postgres into Debezium, CDC, and through Kafka, and finally into the Hudi data lakehouse. And right off the bat, they were able to save. This is them telling us, 1.25 million a year. And this they did a write-up, and it's right on the internet about this. The other really cool thing is they were able to unlock a new AI initiative, a new product, a feature that they were able to put into the product because they were able to handle these large processing jobs that weren't there before. So we'll talk a little bit about why Confluent rather than just Kafka.
Yeah, so I'm going to keep this quick in the interest of time. I mean, I think, so first of all, I would submit that, and from a data streaming Kafka perspective, we have the best, most cloud native, scalable, performance implementation of the data brokering, right? So that's the Kafka. It's inside of Confluent Cloud. We call it Cora, but we can also run on-prem or anywhere you need us. But then above the stream is everything else that you really need to make these reusable data products. It's Flink for processing, it's data governance, it's the security, it's the lineage, the catalog, etc. So like all those are additional capabilities that Confluent brings on top of Kafka.
Perfect. So yeah, and on the Onehouse side, the thing I like about Onehouse over Hudi is that it's so easy to get everything set up, right? It's the other thing, it's all in your own cloud account. It's not hidden away. It's all your resources under your control, no lock-in. But the biggest thing, it's the people behind Hudi. I mean, they know it best. They provide a platform for you that's fully managed. They take all those daily operations and maintenance off your hands, keeps it simple. And again, you're in charge of your data, right? Secure in your own cloud. So we are at the end. I hope you guys are ready to start implementing this unified data architecture in your organizations. We both have links here. You can check out these links to try out both Confluent and Onehouse for free. Get free trials, and you can actually try these architectures for yourself and set this up. Well, yeah, any last thoughts? I think we have just a couple minutes. If there's, any questions that anybody has, we can hang out for a couple minutes. And if anybody wants to throw a question in the chat, happy to answer that. We only have about 2 minutes.
My only thought, Cameron, is we need to up our free trial game. Clearly, you guys are giving.
I can see we beat you in the
Yeah, you did. You
free trial thing there. Yeah, that's embarrassing, I think.
Yeah, I mean, listen, I'm excited about Onehouse and Hudi, and one of the reasons why is, and I talk to customers. I've talked to 4 today already before this webcast. And like across the board, everyone's struggling with how do I make my data accessible to the right tool for whoever has the analytical skill, right? And so
Yeah.
like, Snowflake's great at some things, Databricks is great at some things, and what they don't want to do is constantly move the data back and forth and pay to store it twice, and the processing costs and the networking costs, and then find out, by the way, there's yet something else they want to send to
Mhm.
a vector database or whatever. So like, I think that is the promise that you guys are holding out, and why I am excited about it.
Yeah, and we're certainly excited about, being able to work with Confluent and Kafka, because that is just, tailor-made for the kinds of use cases that we're able to help people with, and it's and it's just a better way to manage your data, doing these streams and the doing this streaming processing and incremental processing. It's fresher, it's faster, it's cheaper, more real time. So we're really excited about it, and I'm really appreciate you joining us today, Will, for this. It was great working with you on this, and really enjoyed doing this together with you guys. I enjoyed getting into the Confluent product as well, and making everything work together.
Yeah, awesome. I enjoyed you doing that work for me as well. So
Awesome. Okay, well, guys, I don't see any questions. You had your chance. I don't see any questions. We're going to bug out. Thanks so much, everybody, for attending today. Have a great day, and we will be talking to you guys soon. Take care.